This is the fourth video talking about chemical formulas, and here we're going to combine our knowledge of coefficients, just the formula in general, and subscripts along with brackets. So when we look at this formula, we can see that there's a 3. So that means that we have 3 of these molecules. 1, 2, 3. Now each individual molecule, if we just ignore that coefficient at this point, you can see that it has 1 calcium in it. So if you just look at this formula at the top here, 1 calcium, and in this formula we've represented that there are OH groupings of atoms, oxygen always adjoined to hydrogen, and we have 2 of them. So each molecule has 2 OH groupings, so there's an OH grouping there and there's an OH grouping there, and we have 2 of them, 1, 2, which is why we get that subscript there. So you can see 1 calcium, 2 OHs here, and that's why the formula is. But you notice that we have the 3 coefficient there. So we have 3 of these molecules. So we want to figure out the total number of atoms. We just do some multiplication. So let's say we want to figure out the number of oxygens. Well, 3 times the 2 here gives us 6. 1, 2, 3, 4, 5, 6. How many hydrogens? 3 times the hydrogens, which we have 2 of for every molecule. 1, 2, 3, 4, 5, 6. We're going to try this example, see if you can come up with the answer. Let's pause the video in a second here after I ask you the questions. How many molecules of this do we have based on this? Okay, if you're back here, you should know that now we have 2 of these guys. The next question is, and you can pause the video after I ask the question, is how many of these NO3 groupings do we have? Hopefully you figured it out that we have 2 of those groupings. Okay, and we can see that right here. So we have 2 of those molecules, 1, 2. We have groupings of molecules, so we actually should have something like this drawn, because each molecule, MgNO3, there's 2 NO3s because of that subscript there, so I should have drawn 1, 2 NO3s, and we'll do the same thing down here too. Like this. So every molecule has 2 groupings of NO3s. You know, how many oxygens total are represented in this chemical formula? Well, 2 of these guys, so and there's 3 of O3s, or sorry, 3 oxygens in every single NO3 grouping, so 2 times 3 is 6. We have 2 of these molecules because of that 2 there, so 6 times 2 gives me 12, and I can check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.